Hello everybody and welcome back to another video of the Linux Noob versus Arch Linux series. And in today's video we will move our Arch Linux install out of the VirtualBox and onto a USB drive. And so to prepare that, first we need to enable the USB for our virtual machine. So I right-clicked on the name of the virtual machine in VirtualBox Manager, and I go to USB and I say enable USB controller and USB 3.0, and here we can add our pen drive, which is the SanDisk Cruiser Force. And first I will uncheck this check mark just for demonstration purposes. So I did that, and I can start up my virtual machine. And as my virtual machine starts up, let me switch to the virtual machine view. So we are booting into our Arch Linux install on VirtualBox. And as it boots up, we are going to cover the method of copying our virtual Linux machine into the pen drive, into the USB drive, for which we will cover 2 pages from the Arch Wiki. And so those 2 pages will be, I will open it for us here in our Firefox browser. So restore session. So moving an existing install into or out of a virtual machine. So this is going to be one of the things we are going to be doing here. And we will of course install Arch Linux on a USB key. So these are the things we will be considering, and you should read these, or at least the corresponding parts, before proceeding with your own things. And so let's open up our URXVT, and if I go LSBLK, then I can only see the virtual hard drive and the virtual CD drive in this machine. So if I go to see what the VirtualBox window has, this header, and I can just go for the USB settings here, and why don't you open? So USB settings, yes, thank you. And I tick the SanDisk Cruiser Force, which is my USB key. I tick it, and now let me just go back to this VirtualBox virtual machine view, and now I issue the lsblk command, and still nothing. Do I need to go? So I have this window here again, devices, USB, and SanDisk Cruiser Force. Do I have to? Yeah, it seems like I have to enable it here in the menu itself. Okay, I was not prepared for that. So now let's get the lsblk command, and now we have SDB for our USB key. SDB is its name, and we will use that drive as the target for our system. So first of all, we need to partition that disk. So now we recognize that SDB is going to be the USB drive. So I need to do sudo cg disk/dev/sdb for our USB drive here. It asks for my password. I give my password, and so this is a non-GPT disk because it was just one disk with one partition, as most of these USB drives are. And so this CG disk will always force the GPT format on these USB keys, which enables us to have multiple partitions with all the advantages of the GPT. You can also read the Arch Wiki based on this. And so this is what we have. We have one partition. This is Microsoft Basic Data. So I was intended to put this system on a USB drive that is 32 gigabytes, but now I only have one spare drive which is 16 gigabytes, so we will have to deal with that. And so hopefully this will be enough for our experiment. So the VirtualBox disk for this is barely above 9 or it's not, it's about 9 gigabytes, it's not even 10. And so here we will have to create the new partitions, but for that first we need to delete the old one, and now we have the free space. So let's create a new partition. The first sector is it's going to be the default, and here, so I want, just to demonstrate, I want to have, maybe we can have 3 gigs of a 3 gigabyte partition for the basic Windows data, which is going to be an exFAT partition, for which the code is 0700. And so this is going to be shared. So because we want our USB stick to be able to use it, and so in our previous video we installed the tools for dealing with the exFAT system, and in the remaining part we will need a EFI partition, which we will generously make 700 megabytes, because we have 2 different kernels and we need the space for both of the whatever it's called, the init RAM FS, so the initial RAM file system image has to be on this partition. So AF00 is the hex code for this kind of partition, and this is going to be just boot. And in the remaining part we will create, so just press enter, and it will be the 8300, because it's going to be an ext4 partition, and this is going to be our root partition. So this is going to be a Linux file system, and so this we can write onto this disk. We have to type yes fully, not yeah. Have to put in yes, because this is going to destroy all the data on the disk, which we did destroy all the data on the disk. So let's quit, and now if I lsblk, you can see that SDB has these 3 partitions that we need, and now we can actually make the file systems on these partitions. So we need to give it the sudo command. It needs to be done as root, and sudo amkfs.exFAT/dev/sdb2. So of course, if your virtual machine is more complicated, you have more USB drives or something, it can be SDB, SDC, SD anything. So take care of what you're doing. This is going to be SDB1. So this is exFAT for SDB1. This is our shared space. This is done very fast. Next one is going to be make file system dot fat-f capital F32. So we need a FAT32 file system for SDB2, which is going to be our boot partition. So if you remember how we did this with the virtual machine when we first installed Arch in our first video, then this is exactly the same thing. So the only thing is we are having smaller partitions because this is a smaller smaller disk. Oh, than we did. Okay, so in the original we had 650 megabytes for the boot, and now we give 700. We are much more generous, or we are wasting space. That's another option. And then we are going to make the file system, so sudo mkfs.ext4-big O, so it's an option, and we will give the does not have a journal, so has journal, and in this parenthesis, and that strange character before has journal, which I don't know the name for, and dev/dev/sdb3. So sdb3 is going to be our ext drive. So now if we issue another lsblk command, lsblk-f, then we can see all the file systems, so exFAT, vFAT, and ext4, which corresponds to what happened to SDA, which is our original the virtual machine. So we had this in the virtual machine, and yeah, you can see same file systems. Okay, I got through this, and now we need to mount. So let's just clear and see it again. So we need to mount these file systems to have them as a directory in the in our virtual machines file system. We need to mount them, and we are going to mount them exactly the same way as we mounted these virtual partitions into the file system from the Arch ISO, from the live environment. So we get dev/sdb3 in /mnt. So we div sdb3. Yeah, I don't put slash into the end, sorry, I got confused. And then we are going to make a directory at /mnt /boot. We have a new directory there, and then we are going to mount to /dv/dsdb2. So sdb2 is going to be our boot partition. So this is why we are going to mount that partition into mnt/boot, which is successfully done. So let's clear the screen and issue another lsblk command to see what's going on. And now you can see that we have managed to mount these two partitions into these two mount points, which is exactly what we wanted to do. And so for copying we would need a package. So here, if you are interested, we have all these in this kind of tweaks for making no journal, having no journal for the extended for partition, and all these things like how do you need this exFAT for being able to continue this drive using as USB storage device, etc., etc. So this is that, and then in this part, for moving out of a VM, you need the rsync package, and this is the command we are going to be running here to have all the important things copied to the drive. And for what does it mean, you should be checking rsync manual, but first we need to get rsync sudo pacman -s rsync. So of course, because you are going to install a new package, you should first make sure that your system is up to date. I just updated this system before I started to record this video, so there's that for that. And okay, let's see, manual rsync. And so in rsync, we are going to be using the dash lowercase a, capital X, lowercase v. So here we have all the options, the options summary. So we use the -v, so it's a verbose, increase verbosity, so we will get more information on what's going to happen. -a is the archiving mode, which is equals to all these options together, which is recursive, which means all the directories will be looked into, and L is copy symlinks as symlinks, P is going to be perms, preserving permissions, and T is going to be modification time, preserving, and etc, etc. GOD. So yeah, you can look these things up. And then we have capital A somewhere, capital A, preserve ACLs. I'm not quite sure what ACL is. And X is preserving the extended attributes. So these are the things. So let's copy this command. Of course, we will need to issue a, let's clear it, sudo, because it needs to be done as an administrator, and I can insert here with shift insert. What happened? Yeah, because of course I need to change the directory names here. So /* is, it means that all the root file system and our target will be /mnt. So we mounted the USB stick to this /mnt folder, and we will exclude dev, which is the devices, proc, which is the running processes, sys, tmp, run, mnt, of course, because we want to exclude this folder itself. We don't want to get into trouble with that. We are not going to copy media and lost and found, and we also won't copy anything called .gvfs from the home folder. This last one is the big mystery for me. Why don't we do that? But anyways, hit enter, and you can see it's copying, and this will take a long time. So I am going to pause this video and come back to it later. And yeah, you should pause this video now if you are copying, and wait until your copying is finished. And I will see you at that time then. Okay, so for me the copying is finished. What did you do while you were copying? Did you watch the output if each and every file and directory was copied well? I didn't. I took a shower. Okay, so what is our next step going to be after this? So we copied everything here, and we will need to change the root into the virtual machine. I mean, no, we are in the virtual machine. We need to change the root to our USB, which is /mnt in this case, but we don't have chroot. So what do we need for chroot? So we can search Arch Wiki chroot. and the Arch Wiki will tell us root is operation that changes the parent root directory, and requirements that using Arch root is part of the Arch install scripts package. So we need to install the Arch install scripts package, which is going to be sudo pacman-s arch install scripts. Yeah, install it for me. So if you notice a cut here, that's because there is a cut, because I did an oopsie. And so what we need to do is, so we have the Arch install scripts pulled down, and we can now root into our USB stick. And in the USB stick, we can perform the next operation of getting our bootloader ready. So we need to root, and so I got into this error, and we can easily avoid that error. So transfer the system and then root and reinstall the bootloader. So that's the part where we are. And so we need to root into the environment, into the disk sudo arch -root /mnt. And now we are rooted into this environment, and we need to get the grub installed the way you should install it on a USB drive, and this is exactly the same way as we installed it in this virtual machine when we started our journey. And this is going to be, I need to check pacman-s if grub and EFI boot mgr are installed on the system, and they are up to date, so very good. Now I can do grub-install --target equals x86_64-EFI and -EFI directory equals /boot and -removable and -recheck. Did I do everything here? Oh, the bootloader ID. I should give the bootloader ID too. This is not here directly, but anyways, we can give it the --bootloader -id equals grub. So it will install grub for this, and this did it without any errors, for which we are very thankful. And now we can make our configuration here with grub-o/boot/grub/grub.cfg. So now it's generating the configuration file for all our Linux LTS, and both the Linux fallback and Linux LTS fallbacks. And now the last thing we have to do, almost last thing, one before the last things, is we need to edit /etc/fstab. Because now we have different UUIDs for our devices. So for that I will open another terminal window, and I will ask for the UUIDs by typing lsblk-f here. So this is going to be the UUID for the exFAT partition, so the control insert, and we are going to press the button, the letter I, for going to the insert mode, delete this, and we will press Shift Insert to insert the proper UUIDs, then go back to this one and get, this is going to be the boot partition. So now we need control insert, and then here we are, come on, going to move here, delete this part, press I and Shift Insert to insert, and escape to escape from the insert mode. And if someone knows Vim better than me, then you can probably delete words. DW maybe? I don't want to screw this up. Yeah, DW. We need to insert a tabulator character here, because this word deletion just deleted that too. Anyways, let's get to, maybe we can, yeah, we can alt tab, press alt plus the tabulator to get here. Control insert this long UUID, go back here, press I for the insert mode and Shift Insert the UUID, press escape, press colon, W and Q for write, and quit. And now, yep, it contains our proper UUIDs. Very good. We did that. So now the system must be able to boot properly and mount. Systemd should be able to mount these partitions as we want them, because it now knows the proper UUIDs. And now the next thing is you have to install video drivers. So if we can close this window, this terminal window here. And so if we go to the tips section here, so these are the packages you should be installing for getting the most wide range of devices to be able to boot with your stick. And so this is the UUID persistent block device naming, we just did that. So what my experiment showed me, that I could basically run most of the system. So you don't want to probably you don't want to need, you won't need 3D graphics or 3D acceleration for the systems that you are going to install on a USB drive. Well, if you are installing on like a USB hard disk, that's the different kind of story, but whatever. If we are just talking about a small USB drive now, so you can probably get away with only installing the Visa driver. So xf86-video-Visa or Visa, I don't know what's the exact pronunciation for that. But my problem is that I have a desktop computer which has a very recent NVIDIA card in it, and so even though the Arch Wiki suggests not installing proprietary drivers, I could not get my computer, my desktop PC work without the NVIDIA drivers. And if you also have the LTS, Linux LTS kernel, then you also need NVIDIA-LTS on your stuff. And of course, if you have like a very recent AMD graphics card, maybe you will need some additional drivers. I am not really sure how it's working. I installed on my other USB the NVIDIA proprietary driver package, and I could still boot up my old laptop, which only has old Intel graphics in it, and I could also use my office computer, which has an older NVIDIA graphics system in it. So whatever, you can try and using it, and if you don't like it, there is some description on the Arch Wiki how to disable momentarily the NVIDIA proprietary drivers when running into troubles with that. So for example, if you have a different computer that does not have an NVIDIA card and for some reason tries to use the NVIDIA driver and fails with it. So what I know is my desktop PC does not work with the Nuvo drivers. Maybe you have an older card which works well with the Nuvo drivers. Whatever, you will see it. You have to experiment with this part a little bit. Everything else was basically smooth. If you have some very weird drivers, for example, or other weird hardware that the drivers are problematic, then, well, you have to deal with that. And what else? So if you go, so Arch Wiki, NVIDIA, then of course it will tell you that every time there is an update for the NVIDIA package, you should regenerate the init RAMFS, and for that you should make this Pacman hook, but that's a totally different story. Now we are going to need to regenerate the initial RAM disk, so it doesn't really matter. Anyway, now we are just waiting and waiting and waiting for this to finish. And the next step will be editing the mkinit.cpio.conf file. Oh, we can do that right now. So let me just start typing here vim/etc/mkinit.cpio.conf. So what we need is we want the init CPI, the initial RAM disk, to have all the stuff in it loaded for any computer that we are going to plug this USB drive in, which means that this auto detect part should be moved somewhere else, because, well, the file systems and the FSCK that can be, so the auto, yeah, so let me take a step back. So if you look up the mkinit CPIO on the Arch Wiki, then you can find the what is this? This is the hooks part, and so this will tell the script that makes the initial RAM disk image what to put in that initial RAM disk image, and when it bumps into this auto detect thing, then after that anything that adds after the auto detect part will only contain the drivers and stuff for the hardware that was detected. And so you want all your, for example, keyboards and block devices to be detected, even though it is not present in the system when you are generating the initial RAM disk, because we are in a VM. So anything we detect will be totally irrelevant for the real system. So this we need to put the keyboard and the block parts before. So we can DW, and can we paste it here with P? Oh no! Where did I paste it? This looks very bad. I am not a Vim master, as you can see. Auto detect and block. And then we will. Okay, let's try again. Let's try it again. So keyboard should be after block. So I will press D, W. Move the cursor here and press P. Oh no, almost though. I did not do a big mistake, just a small one. So udev, base, udev, block, keyboard, auto detect, md, modconf, file systems, and fsck. This is in line with what the Arch Wiki suggests for the initial RAM disk. Where is that? I am not sure about that right now, but anyways, I am quite sure I read it. Yeah, here. The block and keyboard hooks before the auto detect hook. This is it. So this is why we are doing this. So you should understand what this hooks part is for, and press, what is this, comma WQ for saving the file. Let's just check back. Yes, udev, block, keyboard, auto detect. Very good, comma Q. Not comma, it's colon, it's a damn colon. This is the colon character. I am terribly sorry, I misspoke. And the next one, we need to regenerate init cpio, for which we can either say -p linux and then -p linux lts, but there in the help there is this capital P, which will just do all the preset filters. So mk init cpo dash capital P, and it is generating for the Linux LTS default, and then it will also generate, you can see base, udev, block, keyboard, we'll make a fallback, and the fallback one does not have auto detect at all, which means that every single thing that can be relevant to a system is inside this this initial RAM disk. Okay, I'm just testing the new microphone. I'm trying not to directly speak into it, so you don't get that much weird noises. And now I'm just making weird noises just for fun. Okay, we generated the image, so we can now quit or exit. Yeah, we can exit the chroot, and now probably everything is fine. So I can go to my graphical file manager and I can go and see that SDB1. Oh, SDB1 is not mounted. Anyways, file system, I can check MNT, and you can see here's everything. Even if I go to home directory, there is Nice Micro's home, and there is this, all these things. Yeah. Okay. And what else I wanted to check? Yeah, what if I mount this volume? So it's mounted at a kind of a... Oh, sorry. I'm terribly sorry for that. So this is mounted now as a... It's run/media, so it's kind of a... What is the word for it? Come on. Anyway, so it's mounted there, and now I will just make a test.txt and what? No. Display. That's going to be it. And I will just type, come on, this is a test. And then let's save this file. And now that I'm finished, let me go back to the virtual machinery, and here now I will disable this USB. And of course Windows is going crazy about this disk now, and you can see it worked. Test.txt is on the pen drive, on the drive. So now the next thing we have to do is we will have to power off this virtual machine, and we will also restart our real computer, which means that now I have to stop recording, and I will record the boot process using the USB drive on my phone and edit it after this one. So let's reboot. Okay, so now our system is rebooting, so I'm not sure if my computer remembers my boot order, so I'm just pressing F2 with a very high frequency. And now that I am here, I will go to the advanced mode, because why not? Select boot, go to the bottom, and we can just boot override and just boot into this SanDisk, UEFI SanDisk partition 2. And let's see what we got here. Linux. Loading Linux, just starting version 242 dot something. Disk check. Okay. Something. Yeah, we just unplugged the disk. We did not U-mount, we just unplugged it via the VirtualBox, removing the tick, and now I can log in as Nice Micro. Very good. Arch Linux, connection established. Yeah, my clock widget is now in this very awkward position in the middle of the screen. And let's go here. We want to go to Nemo. Let's see. So the shared disk, because we, yeah, this is what Windows did with us. So this is the test.txt. It says this is a test, which is exactly what it should be saying. Very good. Something else we need to check is what else do I need to check? Yeah, Firefox. If I fire up Firefox, let's try this. Restore session. And we are at exactly the same session that we were when we copied the system. What a great thing. Let's close all tabs, of course, and I'm going to open up a terminal just for fun. And of course, the mandatory command is going to be... Oh, it's escaping my mind. Oh, damn. The mandatory command is... Damn. What's that? I have to look it up on the internet. What a shame. Show Linux distro logo. And this will be... Oh, why I don't remember. Oh, NeoFetch. That's it, NeoFetch. Oh my god. So here are all the system specs. You can see that we are running on real metal with an NVIDIA GeForce GTX, and well, that's it. It worked. So I hope you will have luck with your own device, and well, in the next video I will tell you why would you want to do this, or what are the possible reasons to do this kind of USB install. When should you do it, should you not do it, etc. And I will see you then. Bye bye.